Okay, so hi everyone and welcome to my presentation. My name is Hrvoje, I come from Croatia and I'm a senior software developer at a Croatian company called Five. We mostly work for US market. For example, we have projects like Napster, music streaming service and stuff like that. But enough about me, let's talk about this lecture. So today we're going to be talking about JSON Web Tokens. Now, the first thing we need to learn about them is that the term JWT is actually used for JSON Web Tokens. Okay, so JWT equals JSON Web Token. Now, it's important that we know it's important that we understand this because we're going to be using this term quite a lot in the rest of the presentation. Yeah, so we need to make sure we know what it is. So, a quick test. Please raise your hand if you ever work with JWTs. Oof, good. Then you guys don't need me. Okay, let's begin. So the battle between sessions and JSON Web Tokens is actually a battle between references and data objects, and also a battle between stateful and stateless approach. Now I realize that this doesn't make much sense to you right now, but I assure you by the end of this presentation it will. So please keep this in your mind. In the next 40 minutes, we'll focus on what JSON Web Tokens are, how to use them instead of our sessions, and what are their pros and cons with regards to sessions. So let's talk JWT. Now, the first thing we need to do is we need to debunk some of the common misconceptions surrounding JSON Web Tokens, and the biggest one being that it's an authentication protocol. It's not. Okay. It is also not an authorization protocol. So we could say it's not a protocol, right? Then what is it? Well, in its essence, it's just a standard for representing data. So it's just a standard that tells you how to structure your data so that it can be understood by anyone. Right now, you're probably wondering, well, then what's the catch? Well, the catch is in how we use our JSON Web Tokens. So although the standard doesn't say anything about authentication or authorization, its concept is so simple and yet so versatile that it can be used for both of those things, as we'll see a little bit later. But for now, let's take a step back and first remind ourselves of how we use our sessions today, and then we'll see how to achieve the same functionality only using tokens instead of our sessions. Now, this should give us a nice overview of where tokens fit into our ecosystem. So we have our classic client-server communication with users' identity being maintained through sessions. So we have our client, we have our server hosting our web application. When the client approaches the server, he will be prompted for his credentials. The client will enter them, and the request will be sent to the server. Now, what happens on the server? Well, the server will validate those credentials, and if everything goes okay, a new session will be created, and this session will be stored on the server side. And as a response, a session ID of this newly created session will be returned to the client. And then on the next request, the client will send this session ID back to the server. Now, what happens on the server? Well, the server will basically take this session ID and it will find a stored session based on this session ID. And if all goes well, request will be processed and something will be returned to the client. So I mean, this is how most of our applications work today, right? This is nothing special. Now let's see how to achieve the same functionality only using tokens instead of our sessions. So again, we have our client, we have our server. Again, client sent an authentication request to the server, but what happens on the server now? Well, first the server will validate those credentials, and if everything goes okay, a new token will be created. Now this token holds all the relevant information, all the information relevant to our user. So it could hold, I don't know, user's username, user's ID, roles, I mean, whatever is relevant to your user and to your application. But here's the interesting part. So this token is not saved on the server, like with sessions. Instead, the whole token is returned to the client. Okay, so nothing is stored on the server side. And then on the next request, the client will send this token back to the server. Usually, authorization header is used. Can you guys see? Usually, authorization header is used to send the token. Now what happens on the server? Well, the server will take this token, it will validate it, and it will extract the user information out of the token. So again, no user information is stored on the server side. Instead, everything is taken directly out of the token. And then again, if everything all goes okay, request will be processed, and again, something will be returned back to the client. So as you can see, we achieved the same functionality only using tokens instead of our sessions. Now let's do a quick recap of what actually happened here. So when it comes to session, authentication. So when it comes to authentication with sessions, we created the session on the server, and we also stored that session on the server. And as a response, we returned a session ID of this newly created session. Now this session ID was stored inside a cookie, right? On the other hand, with JWT, we created the token on the server, but again, we did not store that token on the server. Instead, the whole token was returned back to the client. So it wasn't a token ID, token reference, or something like that. It was the whole token. And when it comes to storage, well, that's up to the client-side JavaScript. So we did not store it inside the cookie. Okay, so how did we handle accessing resources? Well, with sessions, the client had to send a cookie header containing session ID, and then a stored session was found based on this session ID. On the other hand, with JWT, a client had to send an authorization header containing our token, and then the user information was read directly from the token itself. Okay, so again, no user information was stored on the server side. As you can see, this is how JSON Web Tokens are usually used. But important thing to note here, if you don't want to, you don't have to use them like this. JSON Web Token as a standard is very small, and as such, only a handful of things are defined in it. So stuff like where to store your token or how to send your token to the server, this is not part of the standard. So if you think that there's an implementation that suits your needs better, then feel free to use it. I mean, there's almost no wrong way of using JSON Web Tokens, which is of course sometimes a good thing and sometimes a bad, right? Okay, so now we know how to use our tokens instead of our sessions. Now let's dig deeper into JWT. So JWT. As we all know, JWT stands for JSON Web Token. It's an open standard. It was defined by the Internet Engineering Task Force, and it was proposed as a standard in May of 2015. So it's not that new. In its essence, it's a standard for representing claims between parties, and these claims should be transferred securely and in compact and URL-safe way. Now, three things stand out here. Claims, I mean, what are claims, right? Securely, how to secure our tokens. And finally, this compact and URL-safe way. I mean, what is it? What does it mean? Let's tackle the last one first. So compact and URL-safe way basically means that we should base64 encode our tokens with URL-safe alphabet. So we are using dashes and underscores instead of slashes and pluses, because we all know that plus and slash mean something in URLs, right? Okay, now we'll talk about security a little bit later, but for now, let's talk about claims. So what is a claim? Well, a claim is a piece of information about a subject, and in JWT terms, user is called a subject. Each JSON Web Token is created for a specific user, okay? So there are no general purpose tokens. No, instead, each one of them is created for a specific user, and each one of them holds information relevant to that user. And this information is called claims. So for example, if we have a user named John, then his username would be one claim, his email would be another claim, and I don't know, his ID would be a third claim, okay? And these claims are represented as name-value pairs, with name always being a string, and value any JSON object, any JSON value. That's why it's called JSON Web Token, right? Now let's talk about these claim names some more. There are three types of claim names. We have register claim names. So these would be the claim names that are defined in the JSON Web Token standard itself. You can find them in the standard. Next, we have public claim names. So these would be the claim names that are defined by third parties and register at the IANA, the Internet Assigned Numbers Authority. Usually standards that rely on JSON Web Token define them. So for example, we have an OpenID Connect standard, which is by the way not the same as OpenID standard, that defined more than 20 claim names, ranging from given name to nickname, photo, and I don't know what else. And finally, we have our own private claim names. So these would be the custom claim names defined by JWT users. And who's a JWT user? Well, if your app is creating and using JSON Web Tokens, then you're a JWT user and you can, of course, define your own claim names. But I mean, you should always try to use either registered or public claim names. Why? Well, because they are publicly defined, they're well known, and if you're using them, then everyone knows what you're talking about. On the other hand, if you're using your own private claim names, then only you know what you're talking about. And one more important thing to know here is that all claims are optional. What does that mean? Well, that means that you can create a valid JSON Web Token with 0 claims or a valid JSON Web Token with 100 claims. Okay, so nothing is mandatory. You can put basically whatever you want in your JSON Web Token. Okay, so now that we know what are the claim name types, now let's focus on registered claim names. From now on, I'll just call them claims because it's easier for me and you guys know what I'm talking about. So there are 7 registered claim names, and the first one being the JWT ID. So this would be the ID of the token in question. Again, you don't have to use it if you don't want to, but if you do, then the standard mandates that this value should always be unique for your application. Next, we have the issuer claim. So this would be the name of the service that created your token, the service that created the token in question. Next, then we have the subject. So this would be the subject of the token in question. As we said, each token is created for a specific user. So for example, if token was created for a user named John, then, I don't know, John's ID or John's username would be in this subject claim. Then we have the audience claim. So this would be the intended recipients. You would use this claim if you want to be sure that your token will only be used on specific services. So in that case, you would put a list of allowed service names inside of this claim. Next, we have the issued at claim. So this is the time at which the token in question was issued or created. The value is represented in seconds, so not milliseconds like Java, in seconds since the epoch. And epoch is, of course, January 1st, 1970. Then we have the not before claim. So this claim represents the time before which the token in question must not be accepted by the servers. You would use this claim if you're creating a token that should be used sometimes in the future. And then finally we have the expiry claim. So this is a regular expiry parameter like we have basically anywhere. Nothing special about it, right? And as you can see here, while going through our registered claim names, we actually created our first set of claims. Now, a set of claims is the main part, the data part of the JSON Web Token. So it's the meat, you know, or the vegetables, if you're a vegetarian, of the JSON Web Token. Okay, so this is the data part of our token. An example of set of claims would be something like this. So again, let's say that we created a set of claims for our username John. In this case, we used 4 registered claim names: the ID, the issuer, the expiry, and the subject. In this case, as you can see, the subject is John's username. Let's say something like that. Then we use 2 public claim names, name and email. So as you can see, we input here John's name and John's email, of course. And then finally, we created our own private claim name. In this case, we created a claim called roles, which holds John's roles. So as you can see, so this will be the data of our JSON Web Token. Okay, so now that we know how to create our set of claims, let's see how to pack and secure this set of claims so that it can be transferred to whoever, to other parties. Let's talk about security. Well, when it comes to security, JWTs come in 2 flavors. So we have signed JWTs. In this case, claims are in plain text, And the signature guarantees that the signature guarantees tokens in the integrity. So you can basically you can read the token, but you cannot alter it. The process of signing a JSON Web Token is defined in the JWS, a JSON Web Signature standard. And then we also have encrypted JSON Web Tokens. In this case, claims are encrypted. And this approach offers both token integrity and data privacy. So you cannot read the token and you also cannot alter it. Now the process of encrypting a JSON Web Token is defined in the JWE, a JSON Web Encryption standard. Now I would argue that out in the wild, most of the tokens that you will encounter are actually signed and not encrypted. Actually, encrypted tokens are so seldom used that a lot of libraries don't even support them. They only support signed tokens. So in the rest of the presentation, I'll just focus on signed tokens, and if you're really interested in the encrypted ones, then you can talk to me after the presentation. Now let's talk about signed tokens some more. First of all, there's a whole bunch of algorithms that you can use to sign them, and they're all defined in the JWA, a JSON Web Algorithms standard. But all of these algorithms can be separated into two groups. So we have symmetric key algorithms. Of course, in this case, the same key is used for both creating a signature and validating a signature. And then we have the asymmetric key algorithms. In this case, a private key is used for creating a signature, and the public key is used for validating a signature. Again, I would argue that out in the wild, most of the tokens are signed with symmetric key algorithms. Okay, so now we know how to define our set of claims. We also know how to secure our token. Now let's put all of this together. Let's compose our first signed JSON Web Token. So each signed JSON Web Token consists of three parts. We have the header part. That's the first part. Header holds information about the algorithm used for signing. Then we have the payload part. Payload part holds our set of claims. And then finally we have the signature part, and of course signature part holds our signature. And all of these parts are base64 encoded and separated by a dot, as you can see from the picture. Now let's see how this works on an example. Okay, so first we'll tackle payload. So we'll create an exemplary set of claims. Now what do we need to do? Well, of course, we need to base64 encode this data, and then we put it inside the payload part of our token. Next, we'll tackle header. So we create a header. Headers usually look like this. The important part of this is that algorithm parameter, which holds the ID of the algorithm used for creating a signature. Now what do we need to do? Again, we need to base64 encode this data, and then we need to put it inside the header part of our token. And now finally, we come to the signature part. So how do we create a signature? Well, we need to take encoded header plus dot plus encoded payload, and then we need to sign all of this with our secret key. Result is, of course, base64 encoded, and then finally we put it inside the signature part of our token. And in the end, we'll end up with something like this. So as you can see, three parts, all separated by a dot. Now this is actually a valid JSON Web Token, and we can send it to some service. And if that service has the secret key that we used to sign this token, then this would be a valid accepted token. Okay, great. Okay, so now we know how to create our tokens. We also know how to use them instead of our sessions. Now let's talk about their pros and cons with regards to sessions, of course. We'll start with pros. So the first advantage is that JWTs are self-contained. What do I mean by that? Well, all the relevant data is inside the JWT itself. So user information is represented through claims, and the token also holds the data required to check its validity. It holds signature or whatever. Now, the benefits of this approach on the client side are that the user information can be read directly from the token itself. Okay, so the client doesn't need to contact the server to get the user information. He can do it. He can get this information right from the token. This is especially useful for single-page apps, for example. So if we have a JWT, something like this, we have a subject, name, and role. We could extract this data. We wouldn't have to call the server. On the other hand, if we're dealing with session IDs, I mean, session ID is basically just a string of random characters, so it's not much of a use for us. Plus, we wouldn't be able to touch it because it's in an HTTP-only cookie, right? So yeah, that's not very useful on the client side. And when it comes to benefits on the server side, well, they're coming up next. Okay, so on to the next advantage, and that is that JWTs are stateless. Now, this advantage comes directly from the fact that JWT is self-contained. And because it's self-contained, there's no need for state, so there's no data stored on the server side. Now, while with sessions we have something like this, we would have our server and then we would have our session storage, either in memory or persistent. With tokens, we don't have that. Why? Well, because all the relevant user information is inside the token, inside the incoming token. So there's no need for state. One moment, please. Okay, so on to the next advantage. JWTs are also scalable. Now, when it comes to scalability, we all know that state is evil, right? I mean, state is just a killer of scalability. So if we need to be scalable and we're using sessions, we'll end up with something like this, right? So we'll have a bunch of server instances hiding behind some reverse proxy like, I don't know, load balancer, and we have a session storage. Now, the problem here is that we cannot guarantee that the requests from the same user will always be processed by the same server instance. And because of this, our session storage needs to be accessible by anyone, it needs to always be available, and it needs to be synchronized, which is not something that is easily achievable, right? I mean, technically we could configure our load balancer to send the requests from the same user to the same server instance, but then we have some other issues. So I would say that this is not really a solution, but more of a I don't know. It doesn't matter. It's not really a solution. More of a trade-off, right? Sorry, I forgot the word. Okay, but if we're using JSON Web Tokens, then we have no problem, right? Because we have no state, we have no problem. So no state, no problem. Which means that we don't have to worry about accessibility or availability or synchronization, at least when it comes to user information storage. Okay, so on to the next advantage. JWTs are also more flexible. Now, what do I mean by this? Well, first of all, content of the token is completely configurable, through claims. But more importantly, token creation and token usage can be separated. And this is a really big advantage. So consider this scenario. So we have two services. We have our authentication provider, who's in charge of authenticating the user and creating tokens for that user. And then we have our service provider, whose only responsibility is to basically provide the best service it can. So the service provider expects each incoming request to have a valid token. And if the token is not valid, or the token is not there at all, it will just redirect the client back to the authentication provider. And one more neat thing about this is that the authentication provider, and the service provider don't even have to be on the same domain. So you could literally outsource your authentication concerns. And this is actually the biggest benefit of this flexibility. And you actually probably seen it and you probably used it. If you've seen that sign up with Facebook, sign up with Google, sign up with, I don't know, whatever buttons, well, this is basically it. Someone outsourced their authentication concerns to those social media providers, to those guys. But of course, this comes with a price, and the price being that someone else can create valid tokens for your service. But if you trust them, I mean, if you trust Google, Facebook, or whoever, then actually the setup is quite easy. All you need to do is you need to register your app with the authentication provider, define a set of claims that each JWT needs to have, and you need to agree on a shared key. Now, this shared key will be used by the authentication provider to create, to sign the tokens, and by you to validate those signatures. And finally, on to our last but not least advantage, and that is that JWTs are immune to cross-site request forgery attacks. Now, it's hard to explain what CSRF or session writing is in one sentence, but in its essence, it's an attack in which a user is tricked into making harmful requests to a service he's already logged into. Now, this is a very serious attack, and it relies on session cookies. But if we have no session cookies, then we don't have problems, right? We're immune. And this brings us to the end of the pro section. So let's put them in a list. So JWT is self-contained, stateless, scalable, more flexible, and immune to CSRF attacks. But now we need to think about the other side of the medal, right? Let's talk about cons. Now, the first disadvantage of JWTs is their size. So even the smallest signed JWT is still larger than session ID. So while average session ID plus cookie name is somewhere around 45 bytes, on the other hand, JWT with 0 claims is 75 bytes. And as you can see from the table, as the number of claims rises, so does the overall size of the token. Now let's say that we are using headers to send our tokens. What are the header size constraints? Well, the HTTP defines none, but the servers do. So for example, Tomcat has a limit of 8 kilobytes and Jetty has a limit of 6 kilobytes. But one important thing to note here is that these values apply to all the incoming headers together. Okay, so all the incoming headers together cannot be larger than 8 kilobytes or 6 kilobytes. Now, I mean, you could change these settings. You can change these values in the configuration, but still, size is still something that you need to be aware of. Okay, now on to the next disadvantage, and the disadvantage being the lack of standard when it comes to storage and transmission of JWTs. Now, with cookies, everything is basically handled automatically, right? I mean, the server instructs the browser to store session ID, and then the browser automatically sends the session ID back to the server. I mean, it's all done under the hood, right? Well, on the other hand, with JWTs, you need to do all of this by yourself. So storage needs to be handled by client-side JavaScript, and also transmission needs to be handled by client-side JavaScript. But I mean, it's not that big of a deal. There's a whole bunch of libraries that can help you with this. But still, this is again something that you need to be aware of, and you don't have to be aware of it with sessions, right? Now, JWTs are also more vulnerable to cross-site scripting attacks. Now, cross-site scripting, it's like SQL injection, but for client-side JavaScript. So basically, someone injected a harmful JavaScript into your web application, into your web page, and now this JavaScript is creating mayhem. So this rogue JavaScript can, for example, I don't know, change the data display to the user, or it can make harmful requests to the server. But what it cannot do, it cannot steal your session ID. Why? Well, because it is stored inside an HTTP-only cookie. So JavaScript cannot touch it. But it can steal your JSON Web Token. Why? Well, because JSON Web Tokens are handled by client-side JavaScript, and this is essentially a client-side JavaScript, right? But there is a solution for this, and the solution being that you need to sanitize your user inputs. You're already doing this to prevent SQL injection. You also need to do this to prevent cross-site scripting attacks. Now, again, there's a whole bunch of libraries that can help you with it. So it's not that big of a deal, but you need to be aware of it once more. Now on to the next disadvantage, and that is this signed versus encrypted problem. Now, as we all know, a common use case is to use only signed JWTs, which means that they are readable on the client side. So the data of the token is readable on the client side. Now, a solution to this problem would be to just use encrypted JWTs, but this comes with a price. And the price being that your JWT essentially becomes a black box, which means that the client can no longer read the user information out of the token. Instead, it needs to contact the server to get this user information. But I would argue that for most use cases, using only signed JSON Web Tokens is secure enough as long as you follow these two golden rules. So number one, don't put anything too sensitive inside of your tokens. So don't put passwords or, I don't know, credit card numbers inside of your tokens. And number two, always use HTTPS. So as long as you follow these two rules, I think that you are fine with signed tokens. But still, you can always use encrypted ones if you really want to. And now on to our last, and in my opinion, the only real disadvantage of using JSON Web Tokens, and that is token revocation. So the question is, how to deny access to an already logged user? So if we have a friendly user, a user that logged out of our application, or a user that discontinued his account, then we don't have a problem. With sessions, we would just invalidate the session on the server side, and that would be it. On the other hand, with JWTs, we would just delete the token on the client side, and again, that would be it. But what if we have a harmful user? So a user that somehow hijacked our session ID or our token, or a user that is, for example, banned, but still has a valid session ID or a valid JSON Web Token. Now, how to handle this situation? Well, with session, things are quite simple. All we need to do is invalidate the session on the server side. But with JSON Web Tokens, we have a problem. Why? Well, because there's no explicit way of revoking already issued tokens, okay? There's just no mechanism for that. The standard doesn't define it. So your token can expire naturally in time, but there's no explicit way of revoking a token right here, right now, at this moment. There are only trade-offs. So let's talk about these trade-offs. Well, the first option would be to keep a list of revoked tokens. So basically, each incoming token would be matched against this list. Now, the obvious disadvantage of this approach is that we are introducing state to the server side. Now, the next option would be to make our tokens short-lived. So even if someone does steal our token, he wouldn't be able to use it for a long time. Now, the disadvantage here is that users will need to log in more frequently. But there's a mechanism called refresh tokens that can be used to mitigate this issue. I'll talk about refresh tokens a little bit later. And then finally we have the nuclear option, and we invoke this option by changing the JWT signing key. So this will in turn invalidate all our previously issued tokens. So none of them would be valid anymore. Why? Well, because they were signed with an old key, so they are no longer valid. Now this will take care of our stolen token issue, but this disadvantage being that all our users would be denied access, and all of them would need to authenticate again. So it's more of a, I would say, last resort option, but it's there if you really need it. And this brings us to the end of the pros part of to the cons part of our presentation. So let's put this in a list. So we have size, storage and transmission. We have additional vulnerability to XSS. We have this signed versus encrypted issue. And then finally we have the token revocation. So as you can see here, we have valid arguments on both sides of the aisle. I think that in the end, it all comes down to what's more important to you. Whether is it being self-contained, scalable and flexible, or, I don't know, small in size, well-known and standardized. I think, in my opinion, the only real disadvantage of using JSON Web Tokens is this token revocation problem. And I realize that in certain use cases, this could be a deal breaker. But then again, I would argue that for most applications, just don't require this level of user control. I mean, they're just not doing anything that critical. So this would, in my opinion, be a valid trade-off in certain cases. But again, in the end, it's up to you to make that decision. In this presentation, I just wanted to tell you what JSON Web Tokens are, how to use them instead of sessions, and what are their pros and cons, so that you can make an educated decision. If I manage to do that, then of course I'm happy. And this brings us to the end of the official part of the presentation. Now let's do some QA, but first I'll do it with myself. So this is the only way I'm sure to know the answers to questions. Yeah. Okay. So question number 1. What's the relation between JSON Web Tokens and OAuth 2? Can anybody guess? Okay. Well, first of all, they were designed to solve different kinds of problems. So while JSON Web Token is a standard for representing and transferring data, on the other hand, OAuth is an authorization framework. And because of that, they are actually complementary, which means that we can use them together. A typical use case is the one in which JSON Web Token is used as a vessel to carry information between different parts of the OAuth framework. This is actually, and this relationship is actually defined in an Internet Engineering Task Force standard. It was added as an addition to the OAuth standard. Okay, so question number 2. You mentioned refresh tokens. What are they? Okay, well, first of all, refresh tokens are usually used together with short-lived access tokens. Now, consider this idea. So when the user authenticates, an authentication provider will return 2 tokens. It will return a short-lived access token, and it will return a long-lived refresh token. Now, when we want to contact our service provider, we'll use this access token. And then when our access token, since our access token is short-lived, it will expire shortly. And when the token expires, then we'll use the refresh token. Then we'll use the refresh token to get the new access token. And the refresh token is sent to the authentication provider, and then the authentication provider gives us a new access token. And of course, this is all done automatically under the hood without the user's knowledge. So the user doesn't have to log in frequently. It is all handled by this refresh token. Okay? And finally, question number 3. When would JSON Web Token be a good fit? Well, as I said earlier, it's up to you to make that decision. But you could consider these possible scenarios. So, for example, if you have a single-page app in which your server side is basically just a REST API, then I think that JSON Web Tokens would be a nice fit. Or if you plan on outsourcing your authentication concerns, for example, if you have a smaller non-critical app, or if you have a larger app and want to improve your user experience, because users are far more likely to sign up to your application if they see that sign up with Facebook, sign up with whatever button. In that case, usually a combination of tokens and sessions is being used. And finally, tokens are good for server-to-server communication, for example, between services inside of your organization, like OAuth or something like that. And this brings us to the end of my presentation. Thank you for your time. Just one moment. If you guys are interested in Spring Security Plus JSON Web Token example, then please visit my GitHub repository. Sure.
Thanks. So the question is there a server-side Java library support for the JWTs?
Yeah, of course. You have JWT and you have 3 or 4 libraries. You can find them in JWT.io. They're all listed there. So yeah, you have. I mean, or you can visit my GitHub page, and I already used one of them there.
Thanks.
Okay.
Have you ever seen how how JWT is used outside of authentication of authorization? And could you provide, for example, a sample?
Have I ever seen, what do you mean, for carrying data?
Have you used it not for authorization, authentication?
Okay.
You have started from that it's not authorization, authentication protocol, yeah? It could be used.
It could be used for anything, yes. Well, for
the question is, have you ever used it for
well, I must say that I only use it for authentication and authorization. But for example, in the OAuth, as I said, it is used literally to just carry the data, you know. And so yeah, this would be an example, yeah.
Oh yes, thank you.
Okay. No, you cannot make a question. No.
Thanks for the talk. I didn't get exactly how the refresh tokens work, and
okay.
I want to ask you a little bit detail. When we push the red nuclear button,
okay.
as I understand, the long leaf refresh token isn't going to be invalidated.
No. When you push the nuclear button, everything is invalidated.
A short leaf token and
everything,
long leaf.
Everything.
Yep.
All the tokens that you issued.
So, and what for should we use refresh tokens?
Okay.
When we push this red button, all the users need to be logging again.
Okay, so refresh token is usually used. For example, okay, so here's the setup. So as I said, when the user authenticates, he will get refresh token and access token. Access tokens, I mean, multiple of them. Yes, and usually access tokens are okay, so usually access tokens are not checked against usually we do not check if access tokens are stolen or not, but we do check if refresh tokens are being stolen or not. So we would have unfortunately a list of revoked tokens on the authentication provider, of the revoked refresh tokens on the authentication provider, and then when someone tries to get the next access token, we would just check if his refresh token is still valid or not.
Oh, yeah. Okay.
Yes, I mean, I know it's yes, we are introducing state to our server side, but then again, it's presumed that you would contact authentication server much less frequently than you would contact the service provider. Okay.
So we're relying that the access token will be revoked in short term.
Yes.
Yeah.
Yeah.
Okay, I got it. Thank you.
Okay.
More questions?
Yes, we have 2 more times, so 2 more minutes, sorry.
Thank you a lot for your for your talk. I have one short question. On the slide where you talked about patch of JWT token.
Okay.
In header patch, I saw 2 property, algorithm and type.
So it's far way behind. Okay.
Yeah, the type was JWT. What options it can?
Okay. Sorry. No, still. This. Yeah. You're talking about this. Well, actually, the setup, I mean, the structure of this JSON object is part of the Jose. It's called JSON Object Security and something like that. Jose notation, and just this notation defines that this type parameter should be there. I mean, not necessarily, but. Okay, so let's put it like this. The standard that defines this is created not only for JSON Web Tokens. Okay, so it can be used for other standards, for other protocols, for other standards, and so that's why they added this type parameter. But if you're using it with JSON Web Tokens, then you should either omit it or put JWT. And I really can't tell you what are the other options. I mean, in JWT world, it's just JWT, or actually you can just leave it out.
Okay, thank you.
It's just a general, it's a general standard for that. Yeah. not JWT specific.
So we're almost out of time. Maybe last question. No. So thank you very much for.
Thanks, everyone.